I think now we're ready to start answering a bunch of these time value money questions. I've got a whole load of them here. What we'll do maybe in this first video is answer, maybe we'll answer the first, maybe the first seven if we can get through those. So in the previous video, we learned how to use Excel and a financial calculator to calculate the time value money problems. So I'm going to pull up, what I'll do here is I'm going to pull up our financial calculator on one side here. Let me clear this out. And let me pull up Excel on the other side. Um, I think this will be useful. Let me make this a bit smaller here. Okay, so I'll answer these questions using both Excel and the financial calculator. I think that will be helpful to get you comfortable using both. And we'll work through these problems. I think as we work through problems, I'll introduce new concepts and new problems, and we'll talk about those as they come here. So in number one, it asks, what is the interest rate if the present value is 100, future value is 10,000, and time periods is 5? Okay, so that whenever you come across one of these questions, you have to ask first, what are you solving for? Are you solving for the present value, the reoccurring payment, the future value, the interest rate, or the time periods? And of course, in number one, we're solving for interest rate. Okay. Now recall when I'm using the financial calculator in Excel, I have to put in one of these values, either the present value or the future value as a negative. Uh, and I told you in the previous video that the way I usually do that is I usually try to uh, put the outflow as a negative number. But in number one, in problem number one, there's not, you can't determine which is the outflow, so you just get a pick. Now let's go ahead and put the present value as the negative number. So I'm going to say negative present value of 100, okay, 10,000, and I enter that into the future value function. Zero payment. I'm solving for the interest rate. I'm solving for I over y, but I've got to enter 5 years into my time period function there, n function. And then I compute I over y. Okay. And I get 151.19%. All right. To solve number one in Excel, I say equals rate. Okay. And then Excel, this formula for Excel helps out a bunch. Number of periods is first. I put 5. Payment is 0. Present value is negative 100. Future value is positive 10,000. And then it asks again, do I want the interest to compound at the end of the month or the beginning of the month? And unless I specify in the problem, the answer is always the end of the period. I said end of the month, I meant end of the period, okay? End of the year. All right, so I'm going to close my parentheses there, and I get 151%, which is equivalent of what I got here. In fact, if you want to make sure of that, I can go in here and format the percent and add some decimals. Maybe I'll do that so we can ensure that we're on the same page here. Okay, and that's problem one, solved on the financial calculator or in Excel. Let's do number two. Suppose a Toyota Camry cost $125,000 in the year 2050. The identical car costs $31,000 today. What is the rate of inflation on the Camry? Okay, so look, we got a couple of things going on here. The first thing we got to determine is what are we solving for? And again, in problem two, we're going to solve for I over y. Okay. It says what is the inflation rate of the Camry if the Camry costs $125,000 in the year 2050? Currently, we're in the year 2021, so that's going to be 29 years away. Okay, so my n is going to be 29. My future value is going to be 125. The identical car costs $31,000 today. I'm going to put that as a negative 31,000, and we're going to solve for the rate of inflation here. So I'm going to say 125,000 future value, positive. Again, remember, present value or future value has to be, one of those has to be a negative number. We're going to use the present value again. Payment is 0. Present value is negative 31,000. Okay. We're solving for I over y, and the number of years is going to be 29. How did I get 29? I took the year 2050 minus the year 2021. So I got 29 years in, and I'm going to compute I over y. I get 4.9255%. So that's almost 5% rate of inflation for a car that costs $31,000 today. By the way, that number there is not that far off. Okay, so cars, the inflation rate on automobiles is something probably pretty close to that. So in the year 2050, a nice sedan, not even a luxury sedan, a Toyota Camry might cost us $125,000. Something to think about. To solve for this in Excel, I'm going to say equals rate. Number of periods is 29. Payment is 0. Present value is negative 31,000. Future value is going to be 125,000 positive. I'm determining that at the end of the period. The compounding happens at the end of the period. Close my parentheses. And I should get an interest rate of about 5%. Let me make sure that that's on par. 4.93%. Okay. So number 2 is pretty straightforward. Let's look at number 3. Using information in the answer from problem 2, which is my inflation rate of 4.9255%, what is the Camry going to cost in the year 2030? That's 9 years away. Okay. So what I'm going to do is I'm going to say 4.9255% I over y. So that's my inflation rate. The Camry is currently costing negative 31,000 present value. N is going to be 2030 minus 2021. That's 9 years away. So N is going to be 9. So let me hit 9, enter that into the N function. Payment is 0. And notice that I'm solving. What is the cost of the Camry in 2030? I'm solving for the future value of the Camry. So I compute future value. And that car, which costs $31,000 today, if we assume an inflation rate of 4.93%, is going to cost about $48,000 9 years from now. To do that in Excel, I'm going to say equals future value. My rate is 0.04255. I'm sorry, 9255. Okay, so that was my inflation rate, 4.9255. Number of periods is 9 years. Payment is 0. Present value is negative 31,000. Compounding at the end of the period. As I hit enter, I should get the same number, 47,784 and some change. Good. Let's work on number 4. This is another problem using that inflation rate that we've been working on from problem 2. Using the information from problem 2, in what year will you have to pay $200,000 for a Toyota Camry? Okay, so now we're solving for N. All right. So let's go ahead and do that. The Camry currently costs $31,000. That's present value. The future value is going to be $200,000. The interest rate, I over y, is going to be 4.9255%. Okay. So let's go ahead and start entering this information. Future value is $200,000. Payment is 0. Present value is negative 31,000. Careful on those zeros. Okay. And my interest rate, or my inflation rate, is 4.9255% I over y. So in how many years will I be paying $200,000 for a Toyota Camry? Compute N. 38.775 years. Okay, so that's not too far off. To solve in Excel, I'm going to say equals number of periods. Okay. So this is the function in Excel, N per. I'm going to say the rate is 0.049255. That's my inflation rate from problem 2. Payment is 0. Present value is negative 31,000. Future value is 200,000. Compounding at the end of the period. Hit enter. I get the same number there. Okay. So that's number 4. Let's stop there for this video. We answered problems 1 through 4 here in this video. In the next video, what we'll do is we'll answer problems 5 through 7, and if we have a little bit more time, maybe 8 and 9 here. So anyway, we're just going to break these time value money questions up into chunks. We'll answer these questions for you, and as we go through these questions, what's going to happen is we're going to get more familiar. For instance, in problem 1, we calculated R. In problem 2, we calculated R. In problem 3, we calculated future value. And in problem 4, we calculated the number of time periods. Okay. So we're going to introduce some more concepts as we move along here. So check back on the next video to answer some more time value money questions.